To make a PCB, printed circuit board, design, you'll need to follow a series of steps. Here's a general overview of the process. Schematic design. Start by creating a schematic diagram of your circuit using a schematic capture software like Eagle, KiCad, Altium Designer, or OCAD. Connect the components and define their interconnections. Component selection. Choose the components you'll use in your circuit, considering their specifications, availability, and compatibility with your design requirements. PCB layout design. Once you have the schematic, transfer it to the PCB layout software. Place the components on the board, considering factors like size, heat dissipation, signal integrity, and ease of manufacturing. Arrange the components logically, and define the physical interconnections, traces, between them. Routing. Establish the traces on the PCB to connect the components. Pay attention to signal integrity, avoid crossing high-speed signals, and minimize the length of traces. Use the design rules provided by the manufacturer for trace width, spacing, and clearance. Power and ground planes. Allocate power and ground planes on internal layers if needed. These planes provide stable power distribution and help with noise reduction. Connect power and ground pins of components to their respective planes. Design rule check, DRC. Run a design rule check to ensure that your PCB design adheres to the manufacturer's capabilities and requirements. The software will detect any design rule violations such as trace spacing, minimum drill size, or overlapping components. Gerber generation. Generate Gerber files, which are the industry standard format for PCB fabrication. These files include information about the copper traces, pads, drill holes, and other design elements. PCB manufacturing. Send the Gerber files to a PCB manufacturer or fabricator. They will use the files to produce the physical PCB based on your design. Choose a reputable manufacturer and specify your requirements regarding materials, layer stack-up, copper thickness, and surface finish. PCB assembly. Once you receive the manufactured PCBs, you can proceed with component assembly. This can be done manually or through automated processes such as soldering. Ensure that you follow proper soldering techniques and handle components with care. Testing and debugging. After assembly, thoroughly test your PCB for functionality and performance. Use appropriate testing equipment, such as multimeters, oscilloscopes, and function generators, to validate the circuit's behavior. Debug any issues and make necessary revisions to your design if required. It's important to note that PCB design can be complex, especially for intricate or high-frequency circuits. Consider consulting resources like textbooks, online tutorials, or experienced engineers to deepen your understanding and improve your design skills.